Hi, and welcome to our lesson on inverse trig functions, or in other words, finding angles in a right triangle. So to begin, let's review. If you wanted to find the side of a right triangle, you could set up a trig ratio. Of course, that always starts off with labeling the sides of the triangle. Opposite is opposite of the angle, adjacent is the one next to it, and hypotenuse is the one that's opposite your right angle. So if I look at this diagram here, I know my adjacent side and my hypotenuse, which means I'm going to use cosine, and it's cosine of your angle, or 57 degrees, equals the ratio adjacent over hypotenuse, in other words, x over 23. Now we know cosine of 57 has a value attached to it, so I'm going to rewrite this as 0.5446 equals x over 23. That 0.5446 comes from my calculator. Type in cosine 57. But remember, you need to be in degree mode. Now I have this. I'm going to set this up to look like a proportion by writing an over 1 on the left side of my equation. So now I'm going to cross multiply. 0.5446 times 23 is 12.53. And x times 1 is just x. So this adjacent side of the triangle is 12.53 units. We're also going to review SOHCAHTOA. Find the sine of theta on each triangle. We're trying to find a trig ratio, so we need to label all of our sides. Opposite, adjacent, and hypotenuse. Sine is opposite over hypotenuse. That's the SO. Sine, opposite over hypotenuse. So I write all my ratios and I find sine theta is 3/5, 9/12, and 21 over 35. But make sure we reduce and simplify those fractions, and we find that all the sine ratios are 3/5. This is because these triangles are similar. Notice that first triangle, 3, 4, 5, I could take it and have a scale factor of 3, and I get that second triangle. Again, if I take that first triangle, 3, 4, 5, and scale it by 7, multiplying every side by 7, I get that third one. Similar triangles, we know that the angles don't change, just the side lengths. So we're going to use this property of similar triangles, how you can change the side lengths without changing the angles. In other words, how we're getting these same sine ratios here. And also the fact in the last problem, the cosine of 57 had an exact value to it. And this is going to bring us into finding our angles. To do that, we're going to use inverse trigonometric functions. So an inverse trig function undoes a trig ratio, allowing us to find the measure of an angle in a right triangle when we are only given side lengths. It's kind of like x squared. To undo it, you take a square root, or vice versa. Square root of x, to undo that, you're going to square it. Trig functions and trig ratios are the same thing. There's inverses. So here's our triangle, all labeled for us, and we know our basic trig function ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent's opposite over adjacent. To undo them, we have what's called the inverse. So the top one here says sine inverse of the opposite over hypotenuse equals theta, or our angle measure. Notice how we just switched the position of the ratios and the angle, and then we gave it this little -1 looking exponent. And then it's the same thing for all the other trig ratios, cosine inverse and tangent inverse. One thing to note is sometimes this will be written out as arc sine or arc cosine, arc tangent. They mean the same thing, they're just writing it in different ways. So let's look at how this works in practice with a problem. So finding an angle, find the measure of each angle and round to the nearest tenth, or 1 decimal place. Let's look at angle A, and you can pick any angle, A or B. We know that we can't use C because that's the right angle. But for this problem, let's just use angle A. So I'm going to label these opposite and adjacent because those are the two sides that have lengths. Opposite and adjacent means I want a tangent ratio. That's the first step here. Set up a trig ratio using an angle. So tangent of A equals 20 over 15. Once you have that, you're going to write the inverse. Write the inverse by switching spots. Tangent inverse, write your ratio, 20/15, equals the measure of angle A. And then finally, you're just going to calculate it in your calculator. So second tangent, 20 divided by 15, press enter, and you should have 53.1 degrees. That would be the measure of angle A. This whole expression here, tangent inverse 20/15, has a very specific number attached to it. So if we're listing out our angles, we know A is 53.1. We also know C is 90 degrees. To find angle B, you could go through this process again and write a trig ratio and use inverse, or you can use the properties of triangles. We know all the angles add up to 180, so you can do your subtraction, and you find that angle B is 36.9. Here's another one. Find the measure of each angle and round to the nearest tenth. This time, let's look at angle B. Again, it doesn't matter which angle you want to pick as long as it's not C. But for this video, we're going to use angle B. So I'm going to label all my sides. And these I just labeled the sides with values because those are the ones I'll be using for my trig ratio. Adjacent and hypotenuse means I'm going to want a cosine trig ratio. So set up my ratio. Cosine of B equals adjacent over hypotenuse, or 3/9. I'm going to take that, I'm going to write that as an inverse, switching the positions of the ratio and the angle and adding that -1. So cosine inverse of 3/9 equals the measure of angle B. And once I have this expression on the left here has a value attached to it, so I can put that into my calculator. Calculate. Second cosine 3 divided by 9, hit enter. 70.5 degrees is the measure of angle B. We just solved for angle B, and we found that it was 70.5 degrees. Angle C is 90 degrees, and then we need to find angle A. I personally tend to lean towards the property of triangles having the angles equal 180, as opposed to using a second trig ratio or inverse trig function. So the measure of angle A is 180 minus 90 minus 70.5, which gives us 19.5 degrees. And it's always a good idea to just check, make sure when you add up the three angle measures, they still equal 180. Let's do one more together. Find the measure of each angle and round to the nearest tenth. We're going to use angle B again. It doesn't matter which one you want to use. I labeled my sides opposite and hypotenuse. Opposite and hypotenuse, that's sine. Set up my trig ratio. So sine of B equals 36/53. I'm going to rewrite this using an inverse trig function. Remembering that means I'm going to switch my angle and my trig ratio. So sine inverse of 36/53 equals angle B. And now there are no variables on the left, which means I can put that in my calculator. So calculate, find this exact value, 42.8 degrees. So I list out all my angles. Angle B we calculated to 42.8 degrees. Angle C is still 90 degrees on the diagram. And then I use the property of triangles having their angles equal 180. And I find that measure of angle A is 47.2 degrees. So here's our last problem, and I want you to try this on your own. Here's the steps to kind of help you along. Set up a trig ratio, rewrite it using the inverse trig function, and then calculate. Go ahead, hit pause on this video, try it out, and when you've done that, come back and hit play and find the answers. Okay, great. So you've tried this problem and you're ready for the answers. So measure of angle A is 58.6 degrees, angle B is 31.4 degrees, and angle C is 90 degrees. check them. As long as you're within a tenth, you're usually doing pretty okay. If you're more than a tenth off from those answers, I would go back and check your work, rewatch the video, find out where you kind of went off, and then reevaluate and try again. But let's take this time now to summarize this lesson. So we have a right triangle, and we know how to label it opposite, adjacent, and hypotenuse. Today we looked at inverse trigonometric functions, which is how we kind of undo a trig ratio, and it allows us to find the measure of an angle when we only know the given sides. Remember, this is for right triangles only. And our inverse trig functions we looked at today are sine inverse, cosine inverse, and tangent inverse. And we said the steps were first set up your trig ratio, then rewrite it using the inverse trig functions, and finally calculate it using a calculator. And that's all for this lesson.